All right. So our goal today is to not use a calculator. Okay. If you use a calculator, it's just purely to check that you're correct. But our goal is to not use a calculator. Okay. So we're doing 2B.3 exponential and log forms of equations. All right. So up first, it's important to keep in mind that whenever we're dealing with logs, we should think of it in terms of an exponent. Okay. The base of a log tells us the base of the exponential expression, which we should have kind of caught on from yesterday, right? When we were solving for the variables, notice that our bases stayed the same, right? The base of the exponent became the base of the log, okay? The argument of the log, so the argument is what's in parentheses. That value is what the exponential will initially equal to. So that rule lets this definition, okay? Notice here the log base, so the base of the log is the base of the exponent. Do we see that? The argument of the log is the solution to the exponent. The solution of the log is the power of the exponent. So they can be vice versa. That means you can write a log as an exponent and an exponent as a log. Are you with me? Sort of, kind of. Okay. They can be written vice versa as each other. All right. So once you see it, you're like, oh, miss, that's easy. I got this. Ready? Okay, let's just try it. All right, let's don't panic. So here we have log base 2 of 8 equals 3. The base of the log becomes the base of the exponent. The solution of the log becomes the power of the exponent. And the argument of the log becomes the solution of the exponent. Is that not a true statement? Is 2 cubed not equal to 8? It does. See how that works? You're just rewriting it. So you're writing a log in terms of a exponent. Okay, let's try it again. So again, the base of the log becomes the base of the exponent. The solution of the log becomes the power of the exponent. And the argument becomes the solution of the exponent. Because if you could undo something, that means you understand. Okay, if you can work it front and back, then you got it. All right, let's try really quick. Base of the log becomes the base of the exponent. The equal becomes the power, and the argument becomes the solution. Okay, I'm going to give you 30 seconds to do the last three. Go. So much old grams on that. I'm not defending them, but they are next to each other. They look similar. So the base of the log is the base of my exponent. The solution is my power, and the argument is now my solution. Make sense? How do we do? So we have 16 to the 1/4 equals 2. Then we had 8 to the 1/3 equals 2. All right, so let's talk about what we see in some of these patterns. So notice here, this was just straightforward. The smaller the base, if the argument is bigger than the base, then the number is going to be a small, like a whole number. Here, notice that I have a fraction as my argument, so a value less than 1. So my solution was negative. So that led to me having an exponent with a negative power. So if I have a fractional argument that is less than 1, then I'm going to end up with a exponent with a negative power. Okay. Here, this just follows the rule that anything to the 0 power is 1. So any log base of 1 is going to always be 0. This is normal. 3 times 3 times 3 times 3 is 81. Here, notice that my base is smaller than my argument. And when my base is smaller than my argument, the solution is a fraction. So therefore, my power is a fraction because my solution is a fraction. The argument is the big number in the middle. Okay? When you have a fractional power, what that means is that you're taking the root to that number of times. So I'm looking for the 4th root of 16, meaning what number times itself 4 times equals 16? Well, that would be 2 times 2 times 2 times 2, right? I don't know why that looks like they're negatives, but they're not. Okay? So that's why the fourth root of 16 is 2. Here we have 8 to the 1/3. So again, a fraction of a power means you're taking the root. So the cube root of 8, you're asking yourself, what number times itself 3 times makes 8? And that answer is 2. Because 2 times 2 times 2 is 8. And that's why the answer is 2. Okay? Math patterns. Yay. All right. So let's see if we can go the other way. Can we take the exponent and write it as a log? So taking the exponent and writing it as a log is the next thing that we're going to try to do. So starting off here, the base of the exponent is still the base of the log. The solution of the exponent is the argument of the log. And the power is now the solution. You're undoing it. Remember, if you can go forward and backwards, you got it. Okay? So I'm going to do this one. I'm going to leave you the last 4. So log, the base is 2. The argument is 1/2. And the solution is -1. All right? I'm going to give you 60 seconds to go. See how we did. So here again, the base of the exponent becomes the base of the log. Boom. The solution of the exponent becomes the argument of the log. And the power becomes the solution. How do we do? So we have log base 8, argument 64 equals 2. Then we have log base 5, argument 1 equals 0. And then we have log base 6 of 6 equals 1. Okay, so from here, we have learned some stuff. That was a normal one, normal. Again, this is reinforcing that when you have a negative power, that leads to a fraction of an answer, which means that it leads to a fraction of an argument, right? An argument under less than 1. Okay, notice here, we had a fraction as a power, a fraction less than 1 as the power. That meant that our base was bigger than our argument. This is a normal one, 8 squared is 64. Reverse. Again, testing out our 0 and 1 rule. Anything to the 0 power is 1 means that any log base of 1 equals 0. And this one's a unique rule. So this one is a very important rule. If you have a log and the base and the argument are the same, that equals 1. Because essentially you're just saying that base to 1 equals itself. And anything to the 1 power is always itself. So this is a fancy way of saying 1. No matter what it is, if it's log A of A, it's just 1. Log 1,000 of 1,000 is just 1. If the base and the argument are the same, they equal 1. Okay? All right. So how is this helpful? Knowing these properties is helpful when you're solving log equations. When you're solving a log equation, you want to write it and think about it. Well, you want to think about it as an exponential problem, okay? And the way to do that is first we're going to practice writing it as an exponential. Therefore, when we solve it, we're automatically thinking it that way. Does that make sense? So writing it is you're asking yourself 5 to what power equals 25? That's what you're asking yourself. So 5 to what power equals 25? 5 to what power equals 25? So my answer is 2. Okay, let's try it again. Again, look at the base. 4 to what power equals 64? So you're asking yourself 4x equals 64, and that would be what? 3. Perfect. It's 3, and that's because 4 times 4 times 4 equals 64. It would take 3 4s. So when you look at a log, this is why we say think of it as a exponent. Okay. How I feel? Good. All right, let's keep going. So this one, we're going to think it out loud. We don't have to write it unless you want to. But this is saying 4 to what power equals negative 16? We had a problem on our classwork yesterday, number 8. It's no solution. It's undefined. You can't have a negative argument and you can't have a negative exponent. So it's undefined, NA, whatever you want to write. It's not defined. Okay. Let's keep it going. So this is saying 10 to what power equals 10 to the third power? What would make this a true statement? 3. X would have to be 3. In order for these to be the same, X would have to be 3. Okay, 17. You're saying 3 to what power equals 1/3? It's a fraction, so I know the power has to be what? A negative. And then 3 to what power equals 3? 1. So the answer is -1. Okay, this can also be rewritten. So 1/3 is the same thing as saying 3 to the -1. Okay, let's try a little harder. We have log base 9 of 3. So this is saying 9 to what power equals 3? I know that since it's not 1/3, close though. It does have to be a fraction because the base is bigger than the argument. So it has to be a fraction. 1/2.
Dude, no. Oh my.
1/2. 9 to the 1/2. That means you're taking the square root of 9, right? If I have 9 to the 1/2, that equals the square root of 9, which is 3. Okay. This one's a little tricky. So we have 16 to what power equals 1/2?
Negative?
It has to be a negative. Good call. Not only does it have to be a negative, though, it also has to be a what? A fraction. How can 2 become a 16?
2 times
2 times
power
2.
4.
There we go. 2 times 2. It takes 4 2's to make what? 16. So it would have to be -1/4. Is that what you had in your brain? Should have said it. Should have said it, bro.
My gamer is confused.
How you feel? Okay. It's a pattern, right? It's a puzzle. Little pieces that you got to piece together. All right.